Hello and welcome to Precalculus. This is section 10.4 on hyperbolas. So hyperbolas are formed if you intersect a plane with a double napped cone. So the plane would do something like this, and when it went through, it would make this arch down here and this arch up here. Algebraically, we've never studied them because they're not functions. They don't pass the vertical line test. We're going to think about a hyperbola as a set of all points in a plane whose difference from two fixed points is a positive constant. That means that these two focus points here are the same difference between any point on the hyperbola. So if I took this distance A and then this distance B and I subtracted them, it would be exactly the same as if I took this distance A and this distance B. Subtract those two, you would get the same number. I could do it over here, A, and this one be B. And again, if you subtracted those two, you would get the exact same number. So the graph of a hyperbola has these two parts. It's the first one we've done with two, and they're called branches. Each of the branches does have a vertex, just like a parabola. So just think about it as two parabolas. And then it has two focus points. Just like a parabola has one, these are going to have two. The line segment connecting the two vertices is called the transverse axis. And at the midpoint of the transverse axis is the center of the hyperbola. So of course, like the others, they have their own equation. You'll notice it's really similar to the ellipse. The only difference is going to be this minus. So if you see a minus, you know it's a hyperbola, and if you see a plus, then you know it's an ellipse. And similarly, the equation with C before had the minus, and now it has the plus. So make sure you copy that down onto your appendix. There's also something called asymptotes. So I've written the notes here, but when we actually do a problem, that's when I'll explain them. It'll be so much easier. Number 1 says, find the center, vertices, foci, and the equation of the asymptotes of the hyperbola given, and sketch its graph using the asymptotes as an aid. So we're actually going to start this just like we would for an ellipse. Its center is going to be at 3, -2. And then because this number is 3 squared and it's under the x, I'm going to move 3 in the x direction from my center. And because this number is 5 squared, I'm going to move 5 in the y direction from the center. So the center is at 3, -2. I'm going to move 3 in this direction, 3 in this direction, 1, 2, 3, 4, 5 here, and 5 here. And if I were doing an ellipse, I'd be done. I could literally draw the ellipse. But these are actually more fun. So what you're going to do is you're going to box this out. Okay? It's just a temporary box. And I used these 4 points that I would have used to draw an ellipse. Instead, I'm going to draw a rectangle. And now I'm going to draw my asymptotes. So the asymptotes just go from corner to corner and they pass through the center. Corner to corner and they pass through the center, just like that. So the thing you have to do now is just draw your hyperbola. And the way you're going to do that is if it's x squared minus y squared, you're going to make it side to side. And if it's y squared minus x squared, you're going to make it up and down. And if you don't have an appendix, the way to remember that is that this one makes a y. So the y comes first. So ours is x comes first. So we're going to go side to side. You just follow the asymptote, go right through that vertice, and there you go. It's that easy. If the y had come first, then I would have drawn it this way if it had been y squared minus x squared. But since it wasn't, this is my hyperbola. So these asymptotes are fantastic because they're the guidelines for the whole thing. And now that I've moved this up appropriately, it would go like that. Okay? So let's find the equations of the asymptotes. I have been telling you guys all year that y is equal to mx plus b is actually not the easiest way to write the equation of a line. The easiest way is x minus x1 plus y1. Well, if it was never true before, it is going to be true now. So the slope of this is really easy because it follows the same slope as the box you drew. So from the center to any corner, it goes up 5 and over 3. So it's 5 over 3. And what point does it contain? It definitely contains the center. So x minus 3 minus 2, just like that. That, of course, is just this asymptote. To get this one, it has a negative slope. So y is equal to negative 5/3 times x minus 3 minus 2. But if you still want to use the m and figure out what b is, you go for it, but don't get it wrong. Let's see, what else do we need? The foci. So for the foci, they, like everything else, they're going to be somewhere inside like that. Its equation, though, is going to be c squared is equal to a squared plus b squared. So I told you during ellipses that you didn't really need to know which one was a and which one was b, just do larger minus smaller. Well, now it really doesn't matter because we're just adding them together. So my a is going to be this 3, so a squared is 9. My b is going to be this 5, which is 25. C squared is equal to 34. C is equal to the square root of 34. And that gives you the distance from the center to the foci. So this is approximately 5 point, I'm going to say 8, I don't really know. But the square root of 36 is 6. So it has to be close to that. So 1, 2, 3, 4, 5, somewhere out there. And then the other direction, 1, 2, 3, 4, 5, somewhere out there. That's where those foci are. How do you get their ordered pair? So you have to think about it in terms of x, but since you don't know that exact point, you can just say that it's 3 plus the square root of 34, comma negative 2. And then this one is going to be 3 minus the square root of 34, comma negative 2. And that's how you do that. All right, let's go backwards this time. Let's write the equation of the hyperbola with the given information. Find the standard form of the equation of the hyperbola with foci -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2. So just like last time, the key is to make a sketch. If you don't make a sketch and you get it wrong, don't come crying to me. So I'm going to put the foci at -1, 2, and then at 5, 2. So right away, if those are the foci, then this must be what the hyperbola looks like in its most general form. So I know that it's an x minus something squared, and then minus y minus something squared. And I know it's equal to 1. So I've really got a little bit of it filled in already. To get that center point, the center is going to be halfway between the foci. So since that's a total of 6, 1, 2, 3 is halfway. Now I have my center. My center is going to be 2, 2. So 2 and 2. And then my vertices are at 0, 2, and 4, 2. So now I could actually draw them if I wanted to. It looks something like that. Why do they have to give that to me? Because that's what gives me the distance from the center in the x direction, which is 2. So the number that goes underneath is 4. My c is the distance from the center to the foci. So my c is equal to 3. And now I can use the equation c squared is equal to a squared plus b squared to get that last number. So c squared is 9. A squared is 4. B squared is 5. And that's how we get a 5 to go right there. And we have our equation. It's a little puzzle. You're putting it together. Number 3. So just like with ellipses, we're going to have to always make it equal to 1. So I'm going to divide everything through by 16. And now I can write this equation as y squared over 4 minus x squared over 16 is equal to 1. Remember, you can think of this as y minus 0 squared. It hasn't moved off the center. So my center is 0, 0. I'm going to move 2 in the y direction, and I'm going to move 4 in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. If this were a plus, I would be doing an ellipse, and I would draw it and be done. But since I'm doing a hyperbola, instead of making an ellipse, I'm going to make a rectangle. Once I have my rectangle, I can draw my asymptotes. So now there's two different possibilities for the actual hyperbola, up and down or side to side, using the same exact asymptotes, but only one of them will be correct. So it's your job to know that when it's y squared minus x squared, then it's going to go up and down. And when it's x squared minus y squared, it's going to go side to side. You absolutely have to know that because it completely changes the answer. So since it's a y squared going first, it is going to go up and down. So I'm going to follow the asymptote while I draw it. So I follow the asymptote, I come along and I touch that vertice, and then I follow the asymptote again. It's really wide. If it had been sideways, it would have been really narrow. So just another thing that really makes a difference. So I follow my asymptote, I touch that vertice, and then I come down and I follow the asymptote again. And that's the sketch of that hyperbola. All right, you ready for it to get just a little bit harder? Number 4. So what makes this one harder, of course, is just the format. So we practiced this with ellipses. We're going to do it again. I would put all the x's together and a blank. And then I would put all the y's together. There's no other y's. Okay, so that's going to be nice. 3y squared. And then I'm going to put any extra numbers on the other side. So remember that you can't complete the square while there's a number in front. So I factor out the 4, and you do have to factor out of the blank. That's part of it. And then to complete the square, you cut this number in half, and then you write it square up here. But then it's actually 4 times x squared plus 2x plus 1. So there's a 4 that you're actually adding to this equation. And it looks like that. So this stays the same. This becomes negative 12. And notice now all my steps are complete and orderly. You definitely want to look for that. Your last step is going to be to divide to make it equal to 1. And my final answer on this one is going to be x plus 1 squared over negative 3 plus y squared over 4 is equal to 1, which means that at first glance, it looks like there's a plus between them and it's an ellipse, but this is negative. So if I think of that negative as on top, which you can do, remember, negative 3/4 is the same as negative 3 over 4 is the same as 3 over negative 4. All three of these are the same. So I have a negative on bottom, I'm just going to move it to the top. And then not only that, but now I'm actually going to switch the order and put the negative second so that it looks like the format that I want for a hyperbola. My center is going to be at negative 1, 0. It's easy to do 0, negative 1 by accident because the y is first, but you always have to list the x first. So negative 1, 0. And then, how do I do this? I'm going to go, what squared makes 3? The square root of 3, which is approximately 1.7. So I'm going to go 1.7 in the x direction, and I'm going to go 2 in the y direction. I'm going to make my box. And I use my box to make my asymptotes. Once I have my asymptotes, I have to actually draw the hyperbola, and I decide that based on which of these comes first. It's a y first, so it is going to be going up and down, like that. It does ask me to actually find the foci and the equations of the asymptotes. So the foci, I'm going to use the formula c squared is equal to a squared plus b squared. So c squared is equal to 4 plus 3, which is 7. So c is equal to plus or minus the square root of 7, which means that since I'm going to be moving in the y direction, so square root of 7 is got to be less than 3, right? Because the square root of 9 is 3. So 2 point something. You're making a little graph here. You're not going to get it exactly right anyway, but it's somewhere in here. 1, 2, and then a little something. But the key is to know which point it changed. It changed your y value, not your x. You're still at -1, but now you're at the square root of 7. I didn't have to add it to anything because remember this was 0. So it's 0 plus the square root of 7, and then -1, then from here down square root of 7. So these are my two foci. And last, the equations of the asymptotes, which, like I said, I recommend you use y is equal to m times x minus x1 plus y1, because then you can just always use the center as your x1, y1. So our asymptote is going to be y is equal to m, which we don't know yet, times x plus 1, because it's minus minus 1, and then plus 0. So we just need to find this slope. One's going to be positive and one's going to be negative, but they are going to be the same. So how much did we go up? We went up 2, and then we went over 1.7, which was the square root of 3. So up 2 over the square root of 3, which you might want to rewrite as 2 square roots of 3 over 3. And of course, you don't need that plus 0. You are allowed to write it as plus or minus, as long as you're capable of identifying which one's which. This one is the plus and this one is the minus. But if you haven't tried one on your own yet, you might want to do that. It'll give you a chance to practice completing the square for both of them and getting the equations of the asymptotes and everything else. But of course, I am going to do it for you. So 9x squared, there's no other x's, so I don't have to complete that square, minus 4y squared plus 8y plus blank, and I move the 40 to the other side. Now, I've always said that you can't complete the square if there's a number in front. You especially can't do it with the negative. So not only am I going to take out the 4, I'm going to take out the negative. And this is a little bit tricky for some people. So it's going to be 4 times y squared minus 2y plus blank, which means this is going to become, cut this in half, minus 1. And then when you square it, you get 1. But when you do -4 times +1, you get -4, which means you're actually adding a -4 to this side, so you also have to add a -4 to the other side. Definitely a little bit tricky there. The 9x squared had nothing new, so I'm just going to leave that like that. And now on this side, that becomes 36. Remember that the very last step is to divide through by whatever number's over here, because it has to be equal to 1. And I get x squared over 4 minus y minus 1 squared over 9. 4 over 36 reduces to 1/9. And that means that my center is at 0, 1. And I'm going to move 2 in the x direction, and I'm going to move 3 in the y direction. So 0, 1, 3 in the y direction, 2 in the x direction. If this were an ellipse, I would be drawing an ellipse. But since it's a hyperbola, I'm drawing a rectangle. And then I'm going to draw my asymptotes right through the center and the corners. But then there's still one last step, and that is to know which way to actually draw your hyperbola. Since it's x squared minus y squared, I'm going to do it in terms of the x. So I'm going to follow the asymptote, hit that vertice, and then follow the asymptote. Follow the asymptote, hit the vertice, follow the asymptote. So none of the blue is actually the answer. Just the green is the answer. But you needed all the blue pieces to make it work. It did ask me to find the foci. So I know that they're going to be somewhere out here. So I use c squared is equal to a squared plus b squared. C squared is equal to 4 plus 9, which is 13. So C is equal to plus or minus the square root of 13. Now, most people can get this far, but you've still got to get what that point is. So that point is going to be plus the square root of 13, because x is just at 0. So 0 plus the square root of 13, comma, and it's still at a height of 1. And then this one over here is minus square root of 13, comma 1. And if I needed to plot that, well, the square root of 9 is 3, and the square root of 16 is 4. So square root of 13 is clearly somewhere in the middle. So 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. And that looks good. Last is the equations of the asymptotes. So y is equal to, remember, you can just use that nice center point there, x minus 0 plus 1. And then one of them is going to have a positive slope and one is going to be negative. You can just use the corners of your boxes, or you can, if you want to already have it reduced, go from the center to a corner. So it's up 3 and over 2. Or down 3 and over 2 if you're on the other one. So should you choose to rewrite them, you can do it as plus or minus 3 halves x plus 1. Those are my asymptotes. There's my foci, and there's my graph. All right. Next one. Let's see. I'm going to put my x's together. 2x squared minus 4x plus blank. I'm going to put my y's together. Oh, there is no other y, so I don't have to complete that square. And I get a 4 on the other side. Remember that you need to factor out the 2. So now it's x squared minus 2x plus blank. And then I'm going to cut that 2 in half. So I get x minus 1. I square it and I get 1, but really it's a 2. I've actually added 2 to both sides of the equation. I didn't do anything with this, but I would like you to rewrite it each time so that you have a nice consistent equation. Remember that your last step is to divide through by the number on the other side because it has to be equal to 1. So now I have x minus 1 squared over 3 minus y squared over 6 is equal to 1. And I wanted you to do this one just so you would see it is not always going to be a nice number. We've had a lot with square roots and perfect things, but sometimes it's just not. So let's get all the information down. The center is going to be at 1, 0. 1, 0. This, the square root of this is the square root of 3. So that's approximately 1.7. So I'm going to move approximately 1.7 in the x direction. And then the square root of 6 is, well, square root of 4 is 2, and square root of 9 is 3. So square root of 6 is somewhere in the middle. You're not going to graph it perfectly anyway, so I'm just going to put it around 2.5. I make a box, and then I connect the diagonals to make my asymptotes. Okay. I just have to decide if I'm going to make it up and down or side to side. And since it's an x squared minus a y squared, it is going to go side to side. Just like that. And side to side. They do, as before, want the foci. So I'm going to use c squared, excuse me, is equal to 3 plus 6. C squared is equal to 9. C is equal to 3. So this is a funny dilemma sometimes. I'll have kids be so used to not actually figuring it out. They just say, well, first of all, it's in this direction, 1, 2, 3, and then in this direction, 1, 2, 3. That if they haven't made the graph, they're just going to say, oh, it's at 1. plus 3, comma, 0, and then 1 minus 3, comma, 0. Yeah, you're allowed to do that when it's like the square root of 3 or something that you can't actually add. But when it's a number like 3, you should write down the final number. So, of course, the final number is 4, comma, 0 and negative 2, comma, 0. So make sure you actually simplify. And the equations of the asymptotes. So that's going to be y is equal to, I can use my center, x minus 1 plus 0. And for this one, I'm going to figure out the distance from there to the corner. So we went up the square root of 6, and then we went over the square root of 3. In other words, it's the a and b. And you can memorize that if you want to, but it's just as easy to understand the concept of slope. So square root of 2 times x minus 1. That's the positive one going up, and the other one is negative square root of 2 times x minus 1. So hopefully this also gave you a little refresher on equations of lines. All right, there is still one more. If you have not done one on your own, I really encourage you to try one on your own. I'm going to put the y's together, 9y squared plus 144y plus blank. I'm going to put my x's together, minus 4x squared plus minus 32x. And then whatever's left, I'm going to put on the other side, which is that 548. It's going to be negative. So I factor out the 9, and I get y squared plus 16y plus blank. I cut the 16 in half, which is 8. I square the 8 to put that number there, and that actually adds 576 to this side, so I'm going to have to add 576. And then for this one, I'm going to take out the 4x squared. I'm taking out the negative 4, so this is actually going to become positive 8x plus blank. And that gives me, cutting the 8 in half, is 4 squared 16. Negative 4 times 16 is negative 64. So I'm actually subtracting 64 from both sides in order to complete that square. When I put all those numbers with that negative 458, I get negative 36. So when I divide through by negative 36, that's actually going to make my x positive and my y negative. So I'm going to reverse it. So I'm going to write x plus 4 squared over 9. 4 over 36 reduces to 1/9. Minus, this one's going to be the minus now, y plus 8 squared over 4. 9 over 36 reduces to 1/4 is equal to 1. So my center is at negative 4, negative 8, negative 4, negative 8. And then I'm going to move 3 in the x direction. And I'm going to move 2 in the y direction, just barely fit it. And I'm going to draw my box. The box is what allows me to draw the asymptotes. And the asymptotes are what allow me to draw the hyperbola. So my hyperbola, let's see, since it's x squared and then y squared, is going to be side to side. I guess we don't need that dotted anymore. Side to side, just like that. So let's see, I've sketched it. And of course, find the equations of the foci and the asymptotes. All right, so our foci, c squared is equal to a squared plus b squared. C squared is equal to 9 plus 4. C is equal to the square root of 13. So where am I going with that? So that's going to be like 3 point something. So 1, 2, 3. It's really close, which makes sense because this is a pretty steep parabola. 1, 2, 3, and then this one somewhere in there. So what changed? The x coordinate. So we were at negative 4, but I'm going to add the square root of 13, but I'm still at a y value of negative 8. It is important that you know which one that c goes with. And then negative 4 minus the square root of 13, and I'm still at a y value of negative 8. So those are my foci. And now for my equations of my asymptotes, I'm going to do y is equal to x, I'm going to use my center, plus 4 minus 8. Then I have to figure out the slope. I go from the center to the corner up to over 3, which is your a and your b. You could just write plus or minus, or you could write it out twice. But this one is the y is equal to 2/3 times x plus 4 minus 8. And then this one is the y is equal to negative 2/3 x plus 4 minus 8. All right, that was not only the end of 10.4, but that was the end of our study of conics. Have a great day.